and welcome to the next episode of the Klingberg Wing Mark II development. I'm Raul Klingberg, your host. Today I thought we'd take a moment to review the configuration of the center section of the wing and the pilot's cage before I close it up and you can't see the structure anymore. And I'm getting ready to do that here in a week or so now would be a good time. I know you're a long ways away right now, you can't see a lot of detail, but I'm going to pull you in closer to get a look at the details as we go through them. But just overall, let me show you, we have the center section of the wing, which is made up of a series of ribs, and then the spar carry through top and bottom here, the leading edge tube, and we have the pilot's cage underneath. Pilot's cage is set up on a parallelogram so it can fold up for transportation. And this is carbon fiber and Kevlar tubing, a series of brackets to attach it. The wheels on here are not for landing and takeoff. They're just there for ground handling and pilot protection in case I happen to dork a landing. You might be wondering about some of the hardware, the axles, the cables, and so forth. There are a number of items on here that are temporary just for me to set up the configuration. I cannot make them final until I have the aircraft complete and have done weight and balance and I know where to put the pilot. Then I'll be able to put on real cables and real fittings and hardware and so forth. So don't worry about it just yet. The other key part of the center section is the pilot support system, which is bonded onto a rib back here, a couple of shackles that suspends the pilot. And I'm going to take the leading edge tube out of here first so we get it out of our way. This tube gets bonded inside the D tube of the main wing panel. There's a titanium tube here that provides a slip fitting, comes in here like this. There's no fastener here, fasteners are back here, but this helps support the wing structure and attach the main wing panels to the center section. So what we have here is a 4-point system. This one just slides in. These plates are bonded. These plates are bonded to the shear web of the main wing, and there's a pin here that goes in and out for removing, and there'll be a similar system back here at the rear spar. So we basically have 1, 2, 3, 4 points that attaches the main wing panels to the center section, and it's those 4 points that take both the torsional loads and the bending loads. So let me get this tube out of the way now so we can get a closer look at this whole thing. Get you out of the way. There we go. Okay, so I'm going to walk you through this main structure here and some of the attachment fittings. Let me pull you in a little closer. Okay, now you can get a better look at the internal structure here. There's a series of ribs that provide a variety of functions. Center rib provides mounts for the cables, fore and aft, the tail boom, and the front nose plate, and transfers the loads from the pilot's cage, some of the loads from the pilot's cage up into the main structure of the wing here. These two carbon fiber ribs here, these are foam core, carbon fiber face sheets, and carbon fiber pull-truded cap strips. These are the ribs that carry the pilot loads. The pilot's attached back here to plates that are bonded to these ribs. And when the pilot's loads are put on these ribs and they attempt to bend down, the loads from the pilot are transferred up into the D tube via the pull-truded cap strips. You're probably familiar with those if you watched the previous videos. It's this material. There's 2 of these on the top and bottom of each one of these ribs. These are full length and they run all the way from the aft portion of the rib on up to the tube that connects up to the main wing panels. So this carries the torsional loads that are induced by the loads from the pilot. I also have these on the bottom of this rib. This rib supports the pilot's cage, provides attachment points for it, and we have these across the bottom to carry the extra bending loads that are imparted on this rib by the pilot's cage. Finally, the last rib out here has carbon fiber on the outside, just a little bit of fiberglass on the inside, and it's got carbon fiber on this side for structural integrity and durability because it gets exposed every time we assemble and disassemble the aircraft. Each rib has basswood at the front of the rib to provide the compressive strength that's required in order to carry the loads that go through here. And some of them, I think all of them, I've put on a plywood doubler plate, and like the pilot's cage here, or the pilot's rib and the center rib, they have, in addition to that, carbon fiber doublers to help distribute the loads. There are some plywood doublers on the ribs here to make sure I have a tight fit to the spar carry through. And let's see, what else do I need to cover here at this point? Let's talk a little bit about the wing attachment here. There's a pin in here that attaches these plates. These are 1/2 inch thick carbon fiber plates. They don't have a slot cut on them yet for the shear web, but the shear web will come in here and get bonded on, and it'll have the pull-truded straps over it, just like I did with the spar carry-through, to attach these to the main spar. And to disassemble the wing, we'll pull the pin here and pull the pin at the aft spar, and then we can slide the wing panel off. Now, to get a closer look at the pin, here's the one for the other side. What we have here is a 6061 T6 aluminum tube that's been scuffed up with sandpaper, and there are 2 titanium rings that are bonded on here. The titanium carries all the loads, probably 3 times stronger than it needs to be, but I wanted to keep the weight down by having these as just rings, and the aluminum tube serves just the purposes providing a tool for putting those rings in and getting them out. There's a twist and lift handle here at the top. It's just 1/8 inch diameter piano wire, and a couple of holes through the aluminum tube allows it to fold up and down. These titanium rings are bonded onto the aluminum with a special epoxy that's designed for bonding dissimilar metals. It has a compromise between hardness and flexibility so that it doesn't crack and release these parts. There's actually really only loads that go through here are shear loads like this, top and bottom. There's really negligible loads in this direction, so the epoxy just keeps these rings in position on the aluminum tube. But just to be on the safe side, I've socked a couple of cherry rivets in here, and worst comes to worst, and these come loose, this one cannot go down because the cherry rivets that's there. It can't go up because of the handle, and this one can't move up because of that cherry rivet, and can't move down because the bottom of the skin will be here. This comes into the wing and sits on the bottom wing skin like that. And then in flight, or when it's assembled, the pull handle is normally down like this, and a cover will come over the top, have a little piece of vinyl tape over it to ferret in, and that handle secures the position of the pin, and it can't move up or down that way. So pretty easy to disassemble the wing. We open the cover, pull the pin out, pull the rear pin out, and slide the wing off. That simple. There'll probably be a stooge to help support the wing for solo assemblies. Most of the time I think guys will have somebody to help hold the other end of the wing. The main wing panel is about 18.5 feet long, so about the length of a standard hang glider, and that panel will weigh somewhere around 35, 40 pounds. So having 2 people will just make it much easier. The spar carry-throughs are bonded in here onto the ribs. Actually, the ribs are bonded to the spar carry-through. This will eventually have shear webs in it, and I'm going to explain that here in a little bit. And let me see if I can get you a closer look at the pilot support system. Let's get this tilted the other way, and I'll bring the camera around. Okay, here you see the plate that will support the pilot. There's 2 of these. A couple of shackles here go down to straps that attached to the harness. These plates have a U-shaped channel on them. I don't know if you can see on the other side here. I took standard plates, and then I did an additional layup here on a mold to match these ribs, so that we have a U-shaped channel that slides over the rib like this, and it's bonded on here. The bond bond area is quite large, way more than is needed. It carry all the loads. There's no additional mechanical fasteners there. This plate is much longer than it needs to be, once again because I don't know where the pilot's going to be until I get final weight and balance on the aircraft. The pilot's cage will be shifted forward or aft depending upon where I need the pilot, and then I have a series of holes here. I can finally pick a final location for suspending the pilot. We'll start further forward to have a nice forward safe CG, and then we can move them back as desired. Normally this plate's not going to be this large on a final configuration. It can be much shorter, I just needed this length here because of the wide variance that I could have on where I need to place the pilot. I do have some concepts rumbling around in my head about some type of track system here where in flight the pilot could change his position fore and aft. So for high-speed runs between thermals, he could literally slide his suspension system forward on that track. Essentially what we do with regular hang gliders, weight shift for the higher speed runs, and then when you're thermaling, you track yourself back and set yourself at an aft CG location. And that way we don't have to hold down or up elevon to do the trim condition, but we can just shift the pilot around. But I haven't finished the design on that. It's a prototype aircraft, not really needed here. Wanted to keep it simpler, down and dirty, and get the testing done. Let's see if I can roll this forward a little bit. And let me check the camera and see if you can actually see. There we go. So as you can see, there's a tail boom back here that supports the cables at the back. Helps rigidize the pilot's frame. Not too happy with this one. This is a 1-inch diameter carbon fiber tube. I'm not satisfied with its stiffness. I'm going to go up to 1.5 inches in diameter. And this was set originally at the slope of the upper surface of the wing, and I think that's actually a little low. I'm going to bring this up a bit like this and have it come much further back here. These cables, when you go to recline in the pilot's cage, these cables are actually in the way a little bit. So by putting the boom higher up and further back, it'll get the cables out of the way. Little change that we have to make going forward. So let me take you around to the front end and explain some of the fittings that support the pilot's cage. So here you are at the nose plate, and for all intents, nose plate, just kind of like a standard hang glider. This is a carbon fiber bracket, comes down here, bonded, 2 plates bonded on either side of the center rib, and they provide attachment points for the compression strut up front and the draw latch that attaches the cable system and allows the whole vehicle to be folded up. I bonded on or riveted on a couple of stainless steel plates here. That protects the carbon fiber from getting rounded out from putting the pins in and out all the time, and provides a solid surface for the balls of the ball lock pins. This bolt here will be a permanent bolt. The compression tube stays in place, bolted on here, and at its lower connection point there'll be a lock T-pin system down there. Ball lock system. You pull the pin out and fold this tube aft for folding up the structure. This compression tube takes the loads that might come from the pilot's cage. If you were to drop the nose on a landing and put a large load in this direction, we don't want that to be resolved as a bending load in the pilot's cage. That would put too much load on the pilot's cage. So a relatively small diameter carbon fiber tube transfers the loads from the pilot's cage up into the main wing structure. The draw latch here is secured with a ball lock pin, and to disassemble, one would pull that pin out. The draw latch opens up like this. That puts slack in the cables, enough slack in the cables so that you can pull this other pin here on the other side, take that pin out that way, and that detaches the cable and allows the structure to fold up. And I'm going to show you that a little bit later when it's laying on its side. So that's the front attachment fittings. Nominally, there'll be if a person wants, I prefer to fly open cockpit and take that performance hit, but there'll be a polycarbonate fairing that wraps around here that encloses all of this and keeps it out of the wind stream. So let me roll this a little bit further forward and see if we can take a look at the attachment fittings for the pilot's cage. Let me make sure I got that in frame. I can probably just flip that over like that and see what we got. There we go. You're in frame. So the top of the pilot's cage, carbon fiber tubes with Kevlar over them, protect the pilot in case they get broken. There's just a plate on either side of the rib here with spacers so that it matches the tube. There's a 5mm titanium bolt that goes through here. That bolt runs inside a carbon fiber tube that's bonded inside of this tube. It has some epoxy cotton flocks wrapped around it. That tube prevents someone from crushing the tube this way, from over tightening the bolt, because this is a fairly thin wall tube. Also distributes the loads from the bolt over a wider area of the tube. And there's 4 of these setups as we go around the top, and there's 4 at the bottom. Let me scan you down here now, and let's take a look at the bottom of the pilot's cage. There we go. I think I almost got you there. There we go. Okay, so we have a similar bracket down here, except this is U-shaped. I molded these on just an inexpensive foam and plastic mold as a strip, and then I cut them off. And they're actually bonded right on the tube. They go all the way around the bottom. So this is a really strong attachment fitting here. Same type of bolt arrangement here, running through here. And at this point you can see that there are pull-truded carbon fiber strip at the top. There's 2 on the bottom. I made these bottom tubes here, the horizontals, in order to keep them as light as possible. I made them fairly small diameter, and I made them asymmetrically. It's a thin wall tube, but it needs to take quite a bit of bending if loads get applied vertically in a landing. So to stiffen the tube for bending in this direction, it needs to be really stiff this way. And the most efficient way to do that is to just bond on some pull-truded top and bottom. So this tube is really stiff in bending this way, and less so in this direction, and that's fine because there are no loads no significant loads that get applied that way. So that's the lower fitting. There's 4 of these also. All of this stays in place. There's no need to detach the pilot's cage from the center section to transport the aircraft. Let's see if I need to show you anything else. Oh, let me take you to the back here and show you the tube at the back. You may have seen earlier videos where I did I'm experimenting with this new type of tubing that's a sandwich panel style construction. It's a layer of composites, Air-X foam, and then another layer of composites. Extremely light tubing, and I've never used it before. I've never seen it before. I created it for this aircraft, and I thought this was a good spot to try it out. This is a non-critical component back here, and I can see how it holds up over time. I think it's going to be fine, but this was I had a short piece of it that I could use. I put it in here. It's a good way to test it out. The wheels themselves, I modified them. This is a kid's bicycle wheel. The front wheel actually comes off of a senior walker type thing. I took out the steel race bearings, and I put in a carbon fiber tube for bearing. These wheels don't run fast or for very long on the bearing, so a little piece of 1/2-inch diameter carbon fiber tubing makes a great bushing, and it saves a lot of weight. Okay, so and the front and rear axles will actually be titanium instead of aluminum, and they'll be removable. We'll be able to pull out some clevis pins here and remove them in case we need to replace a wheel or do maintenance on it. Now let's take you back to the front. We'll get you over here. Let's take a look at the front fitting here. There we go. So you see I got some masking tape on here right now. There's a bracket here, and there'll be a ball lock pin that goes through here. This has not been cut to length yet because I don't know where the pilot's cage goes. And I won't be able to drill this out and set it up until I know the final position of the pilot's cage. The front portion of the pilot's cage here might appear to be tubing, but it's not. You might be thinking, gee, Raul, how did you make that shape out of tubing? And I didn't. This actually has a core inside of it. There is a horizontal plywood sheet in here that's made out of 1/8-inch thick light ply, and that light ply has vertical members on it, top and bottom, and then there's foam on either side, and I sanded it to a round shape, and then I took some 2x2 twill carbon fiber, which actually wraps beautifully, and wrapped it around top and bottom until I had a nice stiff structure here. It's really strong, not too terribly heavy, a little heavier than just bare tubing, but it was an easy way to make this shape without making any fancy molds or anything. If you're doing this in a factory, you'd have a mold where you could lay it up like this and it'd be a little bit lighter. These plates are not just bonded on the outside. This is actually slotted, and the plate goes down in there until it meets the plywood that's on the inside of this shape, and then they're bonded in. So plenty strong. Now, I can probably swing you around here and show you the fittings here. The cables attach to the bolts, same bolts that hold the pilot's cage. Just stainless steel tangs that are in here and standard thimbles. These will be regular aircraft cables. And these all stay attached. Don't have to undo any of these for transport. All you have to do is pull the pins up front. One on the compression strut, two on the draw latch that I showed you, and then the whole thing folds up. And we'll show you that here in a bit. Okay, I've swung you around so that you can see the leading edge portion here. This piece of D-tube that I have here goes on the front. This is a bad part. First ones are often bad ones. I have a lot of experimenting to do and refining this process. But basically, this will get bonded on here, just like this. There'll be two of these. They slip on here. They go on like this. They get bonded to the leading edge tube. They get bonded to each rib. And then there'll be a strip down the center here on the outside, carbon fiber, that joins the two halves together. And then I'll smooth that out with some auto body filler and sand it nice and smooth. And then we put the Oracal cover over it. You'll hardly notice. The reason I'm doing it this way, and these final ones will actually be fiberglass on the outside instead of carbon fiber. I'm going to keep the carbon fiber on the inside. This really wasn't necessary for strength. I just thought it'd be easier this way. It turns out it's not. So I'll go back to fiberglass. So we get that out of the way. Okay, once those D-tubes are bonded onto the ribs, I need to make sure that they're securely bonded to every rib and can carry the loads. So once the D-tube is on here and initially bonded, I'm going to reach in from behind the shear web area here, and I'm going to put in carbon fiber fabric in the corners of the critical ribs, especially the pilot support ribs, to make sure that they're securely bonded to that D-tube. And I'll just be able to work on the inside like this from either side. I can reach in on each bay. Some of the ribs are more critical than the others. The pilot's cage support and the pilot support rib are critical. Front area of the center rib is critical. And I'll be able to work that from the inside. And once all of those strips are bonded on the inside here, then I'll be able to put the shear webs in place. I'll come in this way. I have plates already cut, and they come in the backside, and they get bonded to the spar carry-throughs, top and bottom. You might be seeing a little bit of white coloring around here, discoloring. It might look kind of messy. That's actually Teflon spray, and that makes it easy to put the pins in and out. Okay, let's see, what else should I show you? I think that pretty much covers it here. Let me step across your picture here. This is a piece of actual flight hardware. I made this a couple of days ago. This is the skin that goes on the top. Once the D-tubes are in place up front, this goes in the back. This is made oversized, but it'll actually butt on right here like this, right where the pins go in. And there's actually a little valley here in the shape. So what I'll be doing is cutting the inside foam here. I'll just be slitting this a little bit so it can flex enough to accommodate both the shape in this direction and this direction. This is 2 layers of cloth here, 3-ounce cloth on the outside, and I'm not putting anything on the inside at this point because I need to have it flexible to shape it to the wing. When I get ready to bond this in, I'm going to put carbon fiber here on the inside, probably 3-ounce cloth, and let that cure about 50, 60, 70% of the way. And then I'll put bonded adhesive on each rib, and we'll come in, and while that's still flexible, before it's fully cured, I'll get this dropped in place like this, and we'll get it clamped and taped on here and so forth. And that'll be the upper skin. Doing the same thing on the bottom. Bottom surface, actually the bottom's going to go on first so I can get in there and reinforce it, and then this one goes on. So that's how the skins are done for the center section of the wing. Let's see, and last but not least, let me move you around again, and we'll talk a little bit about the control system. Okay, here you're looking at the right-hand side of the pilot's cage, which is where I'm going to put the control system. I have a mock-up here. It has some real parts on it. There's going to be a bushing that this slides into here. If I can get that back on here like this. This will be permanently mounted. There's a support that'll be back here and another bushing. This is the actual control stick itself, its position or its size. Obviously this is a wood mock-up. This will all be 4130 steel tubing. Get my glasses out of the way so I can actually see this. These control horns here will have push rods that go up to torque tubes that are inside the wing. And let me slide this out of here, and I can show you close up how this works. So what we have here is a control stick that goes fore and aft for pitch control, and that will push on this control horn here. It's positioned like this. Let me turn around. This is what it looked like from the other side. So as you push this fore and aft, you'll see that both control horns go up and down in unison, and I just pulled it out of there. We get that back in there. So this is your pitch control. This is the same type of mixer that I used on my original wing. Found out it works pretty well there, and using it again here. And so for roll control, the pilot tilts the stick side to side, and then you see these control horns go differentially. So when they're actually in here and the pilot's running the controls, we're having this action for elevator, and we're having this action where it pivots in these carbon fiber bushings for roll control. So you get differential on the push rods going up for roll control and in sequence with each other for pitch control. So pretty simple, straightforward, just 3 miter gears and some control horns, and there we go, and some push rods, carbon fiber push rods will run up into the wing. Here's one of the fittings that goes up inside the wing. A torque tube goes through here, and there'll be one of these ball end fittings like this that goes on here. I have a series of holes so that I can adjust for throw and loads on this. And so this will be up inside the wing up here, which will get mounted pretty much last. The last component to go on is that center section upper skin that I showed you. The control system will go in, and then I'll close it off. There'll be access holes for inspection underneath. And these control horns that I showed you here on the mixer go up to this and push these up and down for rotating the controls. The torque tube comes across to the main wing panels. This control horn will be inside the main wing panel, and the torque tube from this fitting will come into here. So as this goes up and down, this goes up and down. When we assemble the wing, this comes apart and slides back together again. And these will run to cables that go out to the elevons. So when the wing is assembled, these will be keyed so that they go together at the right setting, and there's no pins or anything required to hook up the controls. They're automatic hookup just like a regular sailplane, except that we're using cable drive instead of torque tubes. So that's how the whole thing is set up, and I actually have the real control stick inside. I just haven't moved components over and started building this all up. Once again, I don't know where this control stick goes. I don't know if it goes up here. I don't know if it goes back here, and that all depends upon where the pilot ends up. So once again, one of the last components that goes in place once I know what the weight and balance of the aircraft is. And it might look like a tight fit, and it is a little bit. I've wondered about that. You know, I thought I could move these over here and put it up higher so that these clear the base tube. I could put them on either side of this post. That'd be interesting. Cable might get in the way. But where I have it set here right now, when it goes through that bushing, there's enough room to put your legs up here. They're over to one side. I won't say that it's a spacious cockpit area, but it does the job. And who knows, there might be a different mixer in the future. I've probably drawn up 50 different designs of mixers. I like this one because it's nice and simple. You buy the components off the shelf. Nothing custom about it. So let me move you around again, and I'm going to show you how the whole thing disassembles and folds off. Okay, here we are. I've set us up in the configuration that you normally will deploy and fold up the pilot's cage and center section for transportation. It's intended to be done with the this component of the aircraft on its side. If you were to do this with the upper surface of the wing on the ground, it's great if you're on grass. If you're on rocks, very bad. So much better to set it up this way. I suspect that people will put a little pad underneath the rib here to protect it from any debris that's on the ground. But this really is the most secure way to do it. Plus, the weight of the pilot's cage itself is borne by the ground. And if you do lose your grip on it, it doesn't flop onto the bottom of the wing and cause any damage that way. Now I've pre-prepared here by releasing the tape on the compression strut, and it normally will fold aft. I wanted to show you how the latching system works here. So this pin comes out and the draw latch is open, and then you can put that back in there. Then you can pull this pin out of here, and then and actually we can close this back up. Put that back there. So these cables will go back. I suspect I'm just going to have a piece of Velcro somewhere to hold those in place. This pin goes back in the nose plate. So the nose, excuse me, we have to put that in after the fact. So the compression strut, I got myself out of sequence. Compression strut goes in like this, then you can put the pin back in. And now the pilot's cage is free to fold up, and it folds aft. And this whole thing swings like this, and the whole thing folds up flat. I don't quite have enough room here in the garage. And there it is. So the overall thickness of this is really not too bad. It's probably not much more than about 1 foot this way. So this will pack in a transportation box quite easily. And there'll be some Velcro straps here to help hold this all together so it doesn't move around while it's being transported. We won't want any damage to occur that way. And this tube will normally sit between those two brackets like that. And that's it. That's how she folds up. So it's really pretty quick and easy to deploy. A limited number of fittings and pins to do to assemble the center section of the wing. And that's it. That's how it all works. At least for now, until I change the design. Once again, let me say thanks for watching. I appreciate all the comments that you put in. Some are absolutely fascinating. Please feel free to ask any questions about stuff I forgot to cover here. And if you have a mind to, I'd be greatly appreciative if you'd click on the link to Patreon and maybe throw a nickel in the pot and help support this project. These aircraft don't come cheap. And I can always use a little bit of help. And but at the very least, I look forward to receiving your positive comments and encouragement to continue on with the project. Keep watching, subscribe, tell your friends. But most importantly, until I see you next time, fly safe and bye for now.